Welcome back to the channel. Today we're diving into one of the most powerful tools in all of chemistry, stoichiometry. Have you ever wondered how chemists know exactly how much product a reaction will make or how much of each reactant is needed? This is where it all begins. In this video, we'll break stoichiometry down into simple, manageable steps. You'll see how balanced chemical equations act like recipes, how to convert between moles, grams, and particles, and how to predict the amount of product formed in a reaction. By the end of the video, you'll be able to tackle basic stoichiometry problems with confidence. So let's get started. Before we start working problems, let's get a little background behind us. If I have grams of substance A and I want grams of substance B, what I will do is I will take my grams of A, multiply it times 1 mole over the molar mass of A times the moles of B divided by my moles of A. I call this the ratio step. This is the only place in the stoichiometry where you use the coefficients in a balance equation. And then I will multiply that times the molar mass of B over 1 mole. So notice now I have 1 mole for the first step and 1 mole in the last step. The only place I can use numbers other than 1 mole will be the ratio step. If I have grams of A and I'm converting it into moles of B, I'll convert it into moles by multiplying 1 mole of A over the molar mass of A times the ratio step. Okay, so that will cancel out to give me moles of B. The next example, moles of A to moles of B. Moles of A, I multiply it times the ratio step. That would give me moles of B. So moles of A, I'm looking for grams of B. I multiply it times the ratio step. Then times the molar mass of B over 1 mole B. So moles A's cancel, moles B gives me molar mass of B. All right, liters of A to grams of B. 1 mole of any gas at STP, which is standard temperature and pressure, is equal to 22.4 liters. That will be the volume of it. If I have so many liters of A, I will take my liters of A times 1 mole of A over 22.4 liters of A times my ratio step, moles of B over moles of A, and then finish it up with the molar mass of B over 1 mole B. So my liters of A cancel, moles of A cancel, moles B cancel, and it leaves me with the molar mass of B. So that's the background on how we're going to solve these types of problems. For our first problem, we're calculating how many moles of water is formed when 44 moles of methane is burned. The prefix meth means 1, so that means I have 4 hydrogens. 2 to 1 is 2, plus 2 is 4. So how many moles of water is formed by the combustion of, so I'll say CH4. I'm combusting, so I'm going to mix it with oxygen. Simple combustion reaction produces carbon dioxide plus water. I like to label everything. So I have 44 moles of methane. I'm looking for moles of water. So we'll start with 44 moles of CH4. All right, we need to balance this equation before we go any further. So in the balance the equation, I need a 2 here. And let's see, 2, 2, 4. Okay, so it's going to look something like this. I'm going to multiply times my ratio step. So my unknown here, I have 2 moles of water over 1 mole methane. So if I say 2 times 44, that will give me 88 moles of water. In our next problem, the combustion of a sample of butane produces 24.46 grams of water. How many moles of butane were used? Okay, bute here. Bute means 4, so it's going to be C to the N, H2N plus 2. So that's C4, 2 to the 4 is 8, plus 2 is 10. So that's butane. So we'll say C4H10 plus O2 yields CO2 plus H2O. Okay, to balance this one, let's see, we're going to need an 8 here. So that's 20. So I need a 10 here. So 10 plus 16, 13, 20, that's 13 here. Okay. So we have our equation. We have 24.46 grams of water, and we're looking for moles of butane. So we'll start with the 24.46 grams of water times 1 mole of water over the molar mass of water. So water, this is 2 plus 16, so that's 18 grams of water per mole. Grams water cancels. Now my ratio step, I put what I'm looking for on top, so I have 2 moles of C4H10 over 10 moles of water. Okay, so moles water cancels. So I'm left with 24.46 times 2 over 18 times 10. That gives me 0.27 moles of C4H10. We have 43.5 grams of barium sulfate is formed from a reaction of barium nitrate and sodium sulfate. So how many moles of sodium sulfate reacted? All right, so that'll be barium nitrate plus sodium sulfate reacts to form barium sulfate plus sodium nitrate. So I put a 2 there to balance it. All right, so I have 43.5 grams of barium sulfate, and I want to know how many moles of sodium sulfate. So I'll start with the 43.5 grams of barium sulfate, convert it into moles. So 1 mole of barium sulfate over the molar mass. Okay, barium is 137.3. Sulfur is 32.1. 4 oxygens is 64. So that has to be 233.4 grams of barium sulfate. My ratio is going to be a 1-to-1, so it's going to be 1 mole of sodium sulfate over 1 mole barium sulfate. Grams cancel grams, moles cancel moles. So I will say 43.5 divided by 233.4. So it would give me 0.186 moles of sodium sulfate. At 32.3 grams of oxygen is formed when potassium chlorate is decomposed. So how many moles of potassium chlorate reacted initially? So let's decompose potassium chlorate. When metallic chlorate's heated, it's going to produce a metallic chloride plus oxygen. Okay, to balance that, I will need a 2 here, a 2 here, and a 3 there. I have 32.3 grams of oxygen. I'm looking for moles of potassium chlorate. So we start with the oxygen. 32.3 grams of oxygen. Convert it into moles. The ratio step will be 2 moles of KClO over 3 moles of oxygen. So grams of oxygen cancel, moles of oxygen cancel, which gives me moles of KClO3. So I will say 32.3 times 2 divided by 32 times 3. That will give me 0.673 moles of KClO3. .8 grams of sodium hydroxide react with hydrochloric acid. So how many grams of water are formed? So my reaction is sodium hydroxide plus hydrochloric acid. So that's going to produce sodium chloride plus water. So as balanced as it is, I have 22.8 grams of this, and I'm looking for how many grams of water. So we'll start with our 22.8 grams of sodium hydroxide. Convert that into moles. Sodium is 23 plus 16 plus 1. It gives me 40 grams of sodium hydroxide. Ratio step is 1 mole of water over 1 mole sodium hydroxide. 1 mole of water on bottom, which is 18 grams of water. All right, so doing the math, we'd have 22.8 times 18 divided by 40, which would give me 10.26 grams of H2O. How many liters of hydrogen gas at STP, which stands for standard temperature and pressure, is formed when 13.5 grams of sodium reacts with sulfuric acid? Sodium plus sulfuric acid is going to make a salt, sodium sulfate, plus hydrogen gas. All right, to balance this, I'm going to need 2 sodiums. I have 13.5 grams of sodium, and I'm looking for liters of hydrogen at STP. Start with 13.5 grams of sodium. Convert that into moles. 1 mole of sodium is 23 grams. Okay, my ratio step, I have 1 mole of hydrogen gas over 2 moles of sodium. And I know that 22.4 liters of hydrogen gas is equal to 1 mole of hydrogen gas. So everything cancels except liters of hydrogen. So I'm going to say 13.5 times 22.4 divided by 23 times 2. So that's going to give me 6.57 liters of hydrogen gas. How many molecules of chlorine gas are needed to react with 5.6 grams of iron to form iron 3 chloride? All right, so we're going to say iron plus chlorine yields iron 3 chloride. So I'm going to need a 2 here, a 3 with the chlorine, and 2 here. I have 5.6 grams of iron, and I'm looking for how many molecules of chlorine. Okay, so I need molecules here. .6 grams of iron. Convert that into moles. Iron on the periodic table, I'm going to write it to 55.8 grams of iron per mole. Okay, the ratio step is 3 moles of Cl2 per 2 moles of Fe. I'm looking for molecules, so I'm going to use Avogadro's number. The molecules of Cl2 per 1 mole Cl2. So I'm going to say 5.6 times 3 times Avogadro's number divided by 55.8 times 2. I get 9.06 times 10 to the 22nd molecules of Cl2. Calculate the mass of silver needed to react with chlorine gas to produce 84 grams of silver chloride. So we'll say silver plus chlorine yields silver chloride. Okay, I'll put a 2 and a 2. That should be balanced. I have 84 grams of silver chloride. I'm looking for the mass of silver. So we'll start with 84 grams. Convert it into moles. Okay, silver is 107.9. Chlorine is 35.45. That adds up to be 143.35. Times my ratio step, I have 2 moles of silver over 2 moles silver chloride. I'm looking for grams of silver, so the molecular weight of silver is 107.9 grams over 1 mole of silver. So it's 84 times 107.9 divided by 143.35 gives me 63.22 grams of Ag. Great work today. You've just taken your first steps into stoichiometry. With just a balanced equation and a few simple conversions, you can now predict how much of a substance is produced or required for a reaction. If this video helped you understand stoichiometry a little better, be sure to like, subscribe, and share it with someone who might need it. Thank you for watching. Goodbye.